Welcome. In this lesson, we are going to be utilizing machine learning to attack and crack a CAPTCHA system. The CAPTCHA system we're going to be looking at is called Really Simple CAPTCHA. It's a WordPress plugin and it is actually being used by millions of users. So as usual, I recommend to be very cautious about usage of the knowledge you gain in this course. Please do not use it for malicious purposes. Exercise common sense. So this is how the CAPTCHAs for the system look. You receive a 4-character code and then you input that same code. As I'm sure you know, there are more advanced CAPTCHA systems out there and those too can be cracked. But for the purpose of learning, let us start with the first step. So let's discuss our plan of attack. How shall we proceed to break this CAPTCHA system? Well, an initial naive thought would be to simply generate a large data set of CAPTCHAs, the details of which we'll have to figure out later, and then use these to train a neural network. Easy peasy. Unfortunately, if you try this simple approach, you'd realize that it's not going to be effective. It's going to be computationally intractable in all likelihood. The problem is that there are about 36 to the 4th power possible CAPTCHAs. If you want your neural network to classify the CAPTCHAs into these categories, then it's going to have about 1.5 million possible classes, and that is too much because each class is going to have such a small amount of data to train on. So what we're going to do is adjust our plan so that instead of detecting the whole CAPTCHA, we are going to crop it into individual characters. And once the task has been reduced to a simple character classification, it is just like MNIST, which we can solve well, and then put it all together into solving the whole CAPTCHA. So our plan will still consist of generating a bunch of CAPTCHAs, cropping them, which is surprisingly non-trivial because the letters sometimes overlap and they don't necessarily stay in the same spot, classifying the letters, and then putting it all together. There are a lot of different options for how we can collect our CAPTCHAs to form our data set. One option is to simply scrape, so attempt to access a system, save the CAPTCHA that's displayed, and add it to the training set. The method we're going to use is simply to generate the CAPTCHAs using the source code, since the source code for a really simple CAPTCHA is available. So having a labeled data set, our next step will be to pre-process it. So we are going to grayscale the images and we are going to crop the letters. And in order to crop the letters, we're going to find the contours and then split those. The main challenge is that these letters, or characters to be more precise, are not always in the same location and sometimes they will overlap. So if we see that 2 characters appear to overlap because the contour, the smallest rectangle that will be containing them, is bigger than that of a single character, then we know that we should be splitting it. So we're going to loop over all these images, crop the letters, extract these, and label them. Most of the letters are fine, but once in a while you will see a pair of letters where there's overlap or some other complication. But because we have such an abundance of clean looking data, we expect that the classifier will still be able to learn and have a good accuracy. Finally, we're ready for the good stuff, which is to train our deep learning system to recognize the characters, and then we're going to put it all together into one system to crack CAPTCHAs. So I'm going to define a helper function to resize the images. I'm going to create a training testing split. I'll label my dataset. Define my network architecture in a pretty standard way for image recognition. There's nothing particularly well thought out about this architecture. Notice that the number of classes is 32, which is not 36, the number of digits plus letters. And the reason is that this CAPTCHA doesn't use O's and zeros and some other characters. because these could be confused for one another, making a CAPTCHA more difficult for human users. We go ahead and fit our model. I'm going to save my trained model. And then for illustrative purposes, I'm going to test it out on one CAPTCHA. So I've chosen this one CAPTCHA 2CXM. We crop the characters just as we have in the training of the model. We predict each character using our neural network. And finally, we put together all the predictions into one predicted text. And in this case, it got it right. More generally, I tested it out and it gets a very high percentage correct. This is how you attack a basic CAPTCHA system. There are more sophisticated CAPTCHA systems that will require correspondingly more sophisticated attacks. But the basic idea is to pre-process the data set in a way that will make it manageable, and then train a machine learning model, and then use that to crack the system. In the next lesson, we are going to use a neural network to perform fuzzing, an approach to finding vulnerabilities in software.